Sound design.
One of the things that I always recommend for people to do when they're in a tuning process is listen. My process builds in a lot of stop and check points.
Sound design. Sound Design Live is produced independently by me, Nathan Lively, in Minneapolis, Minnesota. Welcome to Sound Design Live, the home of the world's best online training and sound system tuning that you can do at your own pace from anywhere in the world. I'm Nathan Lively, and today I'm joined by the co-founder of Rational Acoustics, Jamie Anderson. Jamie, welcome to Sound Design Live.
Thank you, Nathan.
I definitely want to talk with you about Smaart, teaching Smaart, and your early days at Meyer Sound with Bob McCarthy. But first of all, what is your, go-to reference track after you maybe make your first pass of tuning?
I think anybody who's gone to my class knows this. I beat this track into the ground. But one of them is Temptation by Diana Krall off The Girl in the Other Room. It's a track that's really well recorded. It starts off with a bass playing in, so you can kind of hear how controlled or uncontrolled the low frequency is. It's pretty sparse, so you can hear if you've got separation or if you've got a lot of reverb in your way.
Russet brandy in a diamond glass. Everything is made from dreams.
And one of the things I like about it the most, well, besides Diana Krall's voice, is that it repeats phrasing. And I do a lot of A/B sort of listening with filters in and filters out. And also, as you walk, you're doing comparative listening. And so having the same thing repeat itself helps to be able to listen here and then listen there.
We have met each other in person, not like many people that I know from the internet, but you were just here in Minneapolis, and I took your class at the Guthrie Theater.
Yeah, that was a great time. I started off that class in a little bit of physical pain, so I'm sorry for blowing our interview before, but it was a lot of fun, and the Guthrie is a great environment. They were great in hosting us there.
One of my favorite things that you said on the first day of class was that you referred to yourself as an audio communist, and later you called the hammer and wrench button, you called that the hammer and sickle button. So I'm just wondering if there's anything you'd like to confess to the world right now about your political affiliations.
I don't care if people know I'm a democratic socialist, I guess, or whatever you call that. But no, it's just that my job has been trying to get everybody the same show. A mixer's working really hard to create some type of show, as is the artist. And as a system engineer, my job has always been to try and get everybody the same show. It kind of sucks if you're attending a show and as you walk closer to the mix position, the show gets better and better. That's kind of not optimal. If the show sucks, I just want it to suck the same everywhere.
Sure.
So that's why I refer to it as sound communism. There's a lot of tuning that goes on that is, dropping a microphone in place and tuning to make that response to the system at that place sound great, and kind of ignoring the fact that the rest of the place is wildly variant.
Sure, it sounds like that reflects your mentality that instead of making this one place great with this one microphone position, let's think about what we can do to make every place great, or every place the same, I guess is what would be a better way to say it.
Well, what's interesting there is that, and I'm sure we'll delve into this, but the analyzer is going to help you create that uniformity, but really only as far as the system design will allow you. So the fundamental part of getting this, say, sound communism, or the evenness of coverage, the consistency of coverage, starts with the equipment and the system. If you start off with a speaker that sounds different everywhere across its pattern, there's no amount of tuning that's going to fix that problem. And so I do a lot of teaching about solve the problem at the source, which is, fix the system issues. The reason why you have an analyzer is to help you find those problems, but the solutions don't necessarily lie in trying to adjust the DSP. Oftentimes, it's just essentially fixing your system.
I think the 20,000 or 30,000 foot view that you tried to give us on that first day in class was that if your very first step is I'm putting a microphone here and now I'm making the system sound good, then you're probably going to fail, because there are 100 steps before that are really going to set you up for success. You can't fix everything at the end. You can't fix it in the mix.
If all you care about is the mix position, then that's not true, I guess. The whole idea, if I want everybody to get the same show, it takes a lot of preparation. And it's funny because people will come to the Smaart course hoping to learn how to align and get a good sounding sound system. And they're kind of skipping the whole system engineering. I mean, in the course, we're teaching them about a really useful tool to help them in their system engineering. But you've really got to understand the system engineering and system design and start there. And the tool gets introduced sort of later. And I see a lot of people kind of want to just shortcut it and just want to, I want to be a great system engineer, so I'm just going to jump right to the tool instead of first becoming a great system engineer and then being enhanced by the tool.
Sure.
There's one thing that I kind of noticed from my time in the years that I've spent working with analyzers and doing system engineering. A bunch of years ago, when people just started picking up these tools and getting these tools, people saw these system engineers using these new dual channel analyzers and getting great results out of it, because all of a sudden these engineers were able to see, not just the magnitude, the spectrum or the RTA, the spectrum of the signal, but they were able to look at the response of the system both in magnitude and in phase and in time. And so they were able to get these multi-element systems working together and tuned to a level that they couldn't do before. Mm-hmm. But people then saw that and said, hey, this guy used the SIM, the TEF, the MLS, whatever the measurement system was, Smaart. And they looked at that and said, oh, it's the tool. So if I just go learn the tool, that will take care of making the system sound good. It's not. It's like an MRI machine. It enhances the doctor's ability, but the MRI itself doesn't do anything. I start with a joke sometimes. I say, I was feeling really bad, so I went to the doctor and he MRI'd me, and now I feel great.
Yeah, or you could come over to my house and I could MRI you and you'll be better.
Well, in some ways that's one of the things that's pretty amazing is once the laptop computer got introduced to our world, we were able to start realizing these high-powered analyzers in software. So all of a sudden this tool became available. And, I kind of liken it to, imagine if you could run an MRI machine on a laptop. That's great, but that's not going to cure people or make anything better without the knowledge, the medical knowledge that the doctor brings to reading that tool.
Sure.
As you know, I start up in my class. I start and I try and put a framework on what we're going to do, and I try and shoot down people's expectations of this being a magic bullet. It's a really powerful tool, but it's just a tool. And I always say, it's nice that people will say, hey, he smarted a system because my involvement with the platform. But it's a misnomer. Systems are Nathan'd or Jamie'd or Erica'd or Bob'd or Karen'd or whatever. It's just a series of decisions a system engineer makes. It's just that the analyzer tool just is a very powerful assistant in making those decisions.
I feel like I can totally understand that. You know, being a sound engineer is and can be a hard job. There's so many things we need to know. Of course, we would want a silver bullet if it was available. And the story that I often tell people and I describe at the beginning of my book, Master Your Craft, is one of my favorite that I heard from Bob McCarthy a long time ago. The way I understand it, basically, John Mayer and Bob McCarthy were trying to find this silver bullet, and they spent some time doing that in the 80s, and then they couldn't. And then instead they invested in education. And that's now why we have the Meyer Sound Education Program. So if they couldn't do it and they instead turned around and invested in education, then that seems like a pretty strong path for everyone.
I kind of got into this when I became a sound designer in graduate school. I started to figure out that I needed to make my system work, and coming from my undergraduate was in engineering, electrical engineering. I started looking into analyzers and things like that, and I got introduced to a bunch of what was going on. This was in the 90, 91 when this was happening, and one of the people that came up on the radar, one of the companies that came up on the radar when I was looking to do my thesis was Meyer Sound and their work on the SIM system, which is kind of what you're referring to. When I first ran into them, they were talking about, they thought that they were about a year away from auto EQ.
Oh, wow.
And Bob McCarthy became a reader on my thesis and eventually my boss at Meyer a year or two later. And by that time, it was, a couple years away and fading fast. And so it was an interesting time being able to participate in that whole educational development.
I guess the end of the story is that that dream for the silver bullet auto EQ disappeared, and now they have even more complex tools than ever.
We still are looking for not necessarily a silver bullet, but I believe a better tool helps get you farther faster. I believe that there are a lot of people that can make use of this measurement capability, but the level required in terms of the knowledge of the tool and knowledge of the process is prohibitive in some ways. I mean, I've taught a 5-day sim course. I've taught 5-day smart courses, 3-day smart courses, 24 hours of class time, which is what you end up going through. It's a pretty high bar. Auto EQ is the fundamental problem with auto EQ is it assumes that EQ is the thing that's going to fix what you're measuring. It assumes that EQ is the right decision, and in fact, rarely is it. There are very few things that EQ is really a good tool for addressing. Mm-hmm. It's necessary. It's very necessary, actually. But the problems with the system and creating that consistency come more in system design and things like that. That said, we definitely want systems that will auto EQ, that once I've checked all the boxes, got the speakers pointed right, set up right, wired right, we need to be able to work quickly because time is always of the essence. And so we're always pushing to make our measurements more intelligent. Sort of expert user systems is what we're looking at, where you can place a microphone and Smaart can do all the things it needs to do to make sure that that's a good measurement that's being made there. Anything we can do to improve our measurements and kind of protect ourselves from making bad measurements. A lot of users, their first priority is not system measurement, but they need it to get their job done. And so what we really want to do is create tools where You can put a microphone down at the place where you want to measure, and the measurement is going to mind as much of itself as it can. Things like, classic example is, if you're overloading your inputs to an analyzer, why are you using that data, right? And that's something you can monitor. And so systems are becoming more aware of their functionality. You're seeing measurement being folded into the higher end systems out there, which are also aware of the position of all their speakers and the current status on the amplifiers, and all sorts of stuff like that. So all that long-winded ramble right there was to say that we can make our systems more intelligent, more aware of how they're operating, and that silver bullet thing is getting closer. I had a great opportunity to act as sort of a consultant on a large stadium system.
Okay.
The manufacturer for that was D&B, and they had their array processing. All the elements in the system of this huge stadium system were all driven individually. And what amazed me was when they loaded in that system and they first fired it up, the system checked and made sure all of its elements were there. And obviously the system engineers made sure that all the stuff was in the right position. When they fired that system up, the pre-alignment that they had already done on the system, it would have taken me 2 or 3 hours just to get to that point if I had a crew helping me.
Yeah.
And that's amazing. And when you look at the top systems out there, and even the second tiered systems and third tier, we're starting to see prediction and control and things that are allowing people to get to a much more refined level amazingly quicker. So that auto EQ thing, auto EQ is kind of silly, but a system that minds itself and would need measurement, of course, and prediction to be able to complete the whole package. Those are coming, and the big market is not stadiums, although those are the big systems. Big market's your home and your car, and that's the place where you have a much more controlled system. And this is definitely where you're going to see much more intelligent auto alignment built in.
Sure, I like where this is going. I mean, I was just having a conversation recently with a friend, and we were talking about how amazing it is, or how amazing it would have been if 20 years ago when we were starting, if we would have had wireless mixing on iPads. Like, we never thought of that. That would have been so cool and so helpful. And I'm sure in a few more years, we'll wish, what if we had had these amazing, aware systems 20 years ago when we were first starting. So I like the direction it's going in. And it also makes me think of that Apple speaker that Apple put out this year, I think. And it has some microphones that, have some awareness of what the room is like and the reflections there, and can help with, balance and intelligibility and things like that. So yes, it sounds like systems are definitely getting smarter and easier to use.
That's one of the things that we've been looking at a lot over the last 2 years here, is coming up with ways of getting actionable data, more reliable data quicker. By that, what I mean is that if you take a less sophisticated user, and I don't mean somebody walking in off the street, but I mean, when I say less sophisticated user, a mix engineer, and they are incredibly sophisticated in their world, but they are not necessarily really deep on system engineering and or measurement. And do they really need to be? But they need to make use of the information that the measurements produce. And so we've been working a lot, and actually there's a bunch of standards committees that are working on it. And how do we get data that you can make good decisions off of, and how do we get data that quickly, so that we can make these decisions not in 2 hours of noise, but in 5 minutes worth of measurements.
When I'm first talking to someone who's new and wanting to get into an audio analyzer of some kind, get into system optimization, one of the first things we have to talk about is just setting up the system. And there could be, I have like a 12-point checklist just verifying your data, verifying that you have all the physical connections, the software settings, all these things. And that can be, prohibitive for someone, an expert who's wanting to get set up quickly, or, a novice who is just starting out for the first time. So even in those little areas, I can see how if, we could turn that 12-point checklist into a single point in the different areas where, we're working, sure, that would help speed things up.
I've done training for a lot of people, and oftentimes I'll see them later in the year or years later and ask them, have they been using the analyzer, what they've been up to. And oftentimes I'll get this comment that, I haven't really been using the analyzer because it takes too long to set up.
Mm-hmm.
And basically, in the real world, there's time compression where you had 2 hours, but then that 2 hours evaporates, and now you only have 15 minutes. And as you know, I said this in the class, if it takes me 10 minutes, 15 minutes to set up and verify, sorry, but if it takes you 15 minutes to set up and verify your analyzer, then it's not a useful tool to you because you couldn't apply it. And so one of the things that we really stress is the ability to quickly set up and configure and adapt your measurement environment. And that makes a usable tool. I gotta say, one of my favorite tools ever, and this is going back, was the VariCurve remote for the BSS VariCurves. Okay. Did you ever see that before?
No, I know of BSS, but I don't know about the remote.
Oh, this is digitally controlled analog EQ. The thing about it that I just loved was that it was so intuitive that I could, and I don't mean to bash on my mother, but this is a good example. As I always said, I could take that VariCurve remote and hand it to somebody, and like my mother, and they would look at it and say, okay, I've got 16 equalizers that I'm controlling, and I see 16 buttons over here. I hit that, and I can I touch here, and I place a filter, and here's my gain, here's my Q, here's my frequency knobs. And it was so incredibly intuitive and easy to use that as a system engineer, I could just wield that as a weapon. So we're always working on ways to simultaneously make it more powerful, but also make it more intuitive and let the workflow. We work on workflow and controllability and things, because just because an analyzer can do something doesn't make it useful.
How about a t-shirt that says Rational Acoustics, protecting yourself from yourself since 2008?
Don't care in that.
Hey, did you know that I have an online course on sound system tuning?
No.
I do.
What's it called?
It's called Pro Audio Workshop Seeing Sound.
That's a funny name.
Yeah, it's kind of funny.
Okay. Do you want to read me your ad copy?
Sure. Pro Audio Workshop Seeing Sound is the world's best online training in sound system tuning for live sound engineers that you can do at your own pace from anywhere in the world. Improve your confidence and consistency through step-by-step lessons that walk you through speaker placement, aim, EQ, and crossover alignment. Unlike other online courses, Seeing Sound has the highest level of support in the industry. That means that you get 24/7 priority support from me and a dedicated group of your peers through instant messaging. And all of that comes with a 100% 30-day money-back guarantee. For more information, go to proaudioworkshopseeingsound.com. All right, Jim, you have to give me an example of the 8-ball. So what is a question that you would ask, and what is a potential answer?
Hold on. I just happen to have one right here.
Excellent. So should I ask a question?
Sure.
All right. What is the delay between my main and my outfill?
This is blame phase. Let's try again. Here's an answer. Beer.
Okay.
This one says, turn it off and on again. This says, plus 3D. The funniest thing was that we debuted version 8 at Music Messe in Germany. And we didn't know that the Germans didn't have the magic 8-ball. And so we're showing this at the swag on the booth, and they like, voces los. They had no idea what it was because they never had any reference for the toy.
Everyone wants to know how to work faster. We've talked a little bit about it already, so let's talk a little bit more about using Smaart. If there's one thing for sure at every show, it's that there's never going to be enough time. You mentioned time compression. So I want to ask you what you do to save time in the field. And you already mentioned you have to be able to set up the audio analyzer quickly. It can't take you an hour. It has to be, pretty quick. Can you use something from your own personal experience, or maybe something that you see that you do differently that helps you work quicker?
Preparation is alignment is a series of decisions that are being made. The actual decisions that are where you're going into time compression are the amount of time when you can actively make noise and potentially have control of the system, have the space. There's a lot of stuff you can do when you can't make noise through the system, and there's a lot of stuff you can do 2 days before when you're packing the truck, or you're responsible for every piece of equipment, which includes all the cables. One bad cable can turn $1 million sound system into an AM radio. It doesn't mean, though, that you wait till you got your 15 minutes left and check all your cables. I mean, that's ludicrous. You build a process that allows you to check everything as it goes. When I was touring with ultrasound, we could tune a system for an arena or a shed or an amphitheater. Might have 15 individual speaker systems. We could tune that in 15 to 20 minutes, touching all the systems, verifying everything. That's kind of disingenuous, because the very act when you're loading in, you're doing spin tests on amplifiers, and you're checking and verifying that things are aimed properly. And so it takes a methodical approach, if you're juggling a whole bunch of elements, to being able to make sure stuff is in the right place, so that when I only have 15 minutes to make a measurement, you're going to be in good shape. Quite honestly, the actual measurements themselves only take 15 seconds. Mm-hmm. It's not like it takes a long time, and we've been talking with a few different live sound providers, let's say large touring companies that rhyme with pair, and never mind, don't say that. But the thing is, we've been talking with these providers about cutting the actual measurement window down to as minimal as possible, because it's not necessarily disruptive, but it's time that doesn't allow other people to work in the space, let's say, or and a lot of this stuff, the actual measurement stuff, really only takes up an actual couple minutes of time. It's a matter of then you can offline go and make your decisions, what you're doing, and obviously what you want to do before you even, like that example I was talking about with the stadium system. There's a lot of stuff you can do in pre-work to get yourself 80% of the way there. And so that when you turn on the sound system, you're almost done. There's still a lot of work to do, but the system alignment stuff hopefully is sorted in a short period of time. There's a lot of work that goes into prepping a rig for a tour. And there's a lot of work that goes on that's about monitoring that stuff is working. And what's really brilliant is there's a lot of systems out there, particularly with the self-powered systems or the dedicated power systems, that are able to monitor and verify that everything is working properly, so that when you do have that 15 minutes, you can get right to asking those alignment questions. What's the delay time here? What's the general frequency response?
So, Jamie, it sounds like you're saying that not only do I need to make a checklist to prepare, but basically once I get into the field, I need to have most of that stuff checked off.
My first step out into actual touring and being responsible for the whole thing not just a white glove analyzer operator, was on Katie Lang, and we had a brilliant mixer slash production manager, a guy named Grant Mackery. It was a great learning, a great place to learn about what it takes to make a tour happen, to make a system happen, daily. And it was quite interesting that the first couple of stops on the tour, I could get the system in there up tuned, no problem. But when everything came down, I ended up standing in a pile of cable stage right. It was just a huge tangle of cable and big problems.
Spaghetti.
And my speed of loadout was horrible. And being taught how to load in for the loadout and how to prep your system so it goes in faster. I love that world of tour engineering where you're just sitting there and you're optimizing things. And a lot of that's because you try to make it as quick and efficient as possible because you never know what's going to be pitched at you any given day, whether it's weather, whether it's a piece of steel falling from the high grid or something like that. I mean, there's just crazy stuff that happens where all of a sudden you lose a bunch of time. So working with guys that have been doing it for a long time, it's just built into their process of the way that they tech the rig. They go through and verify the whole system, they set up the system in the shop. You want to see those. You can go look at Rat publishes a lot of pictures online now of their system setups as they're getting ready to do these big events.
Sure.
It's the pre-work that really makes you powerful. One of the most insidious things is a bad cable, where you assume the cable's working, so you're looking elsewhere. I've had a situation during a festival where an NL4 speaker cable went bad just from vibration, and all of a sudden we lost a major part of the array.
Oh my God.
And so we're looking at everything except the speaker cable, and it took a long time to figure out what the problem was.
So in online forums, I will regularly see this question come up. I'm working in a highly reflective room tomorrow. What should I do? What are your tips? And then people have all these tips like, oh, you should do this, you should do that. And one of the most common ones that I'm always confused by is someone saying, you should keep the volume low. And I always think this is misleading because rooms are linear. Changing the volume doesn't really change anything, does it? So the room shouldn't affect the drive level. So what's really going on here?
Well, first, if you can, just tell the people to ignore the reverb. That's no. You're right. What a mixer knows is if you have open mics on stage and you have a really live room, if you turn up the system, you'll get into trouble. But that's regeneration. That's not that the room is changing or you've over-energized the room. It's that the reverberant energy getting back into the microphones is a problem. So somebody's sitting there and they go and turn up the vocalist to get them above the mix and to really get them to come out. But what they've done is not only has the vocalist's level come up, but the reverb that's getting back into the microphone. When the real solution is to get the microphone closer to the vocalist or have the vocalist get louder, those are the solutions. But anybody who's mixing a really live room knows that you can't overpower it. You have to create space in the mix, because if you've got a lot of energy hanging out in the room, you've got some sort of masking that's going on there, and so you've got to be more aware of that. But it's so there is a real skill for being able to mix in these big reverberant rooms, and it's not level per se. That's like you turn it up and you are changing the response of the system as the room, as you just said. But you are liable for that. The solution to the problem from my side of it is you're trying to get better direct to reverberant ratio, is control where you're throwing your energy. And that's a lot of systems out there are pretty amazing at being able to adapt the pattern, or at least adjust the pattern of the speakers to where the bags of water are sitting and not lighting up the rest of the room. And I would say a major portion of it we saw when line arrays came out and really became prevalent. One of the major things they did was got control of the vertical pattern of the mids and lows. And you had all this low mid, that type of stuff coming off your array, going up into the ceiling and raining back down. And so once these line arrays got vertical control, you get the line long enough that you're not throwing 250 cycles into the roof. You're throwing it on the bags of water in the seats.
Yeah.
You got just a nice tighter feel. Before we were just relying on the high frequency horns, so we could get okay direct reverberant ratio or clarity up above 1K or something like that. But you got below that into the fundamentals and formants of the voices, and you got mud. And so that was one of those things that changed the game. But now you look at stuff out there like, MLA or Anya or the array control stuff. That's the stuff that's the big game changer for these reverberant environments. There's a bunch of vocal speakers, column speakers out there that came out in, say, the 2000s, where you got pattern control and with the array of these 5-inch drivers. I saw when I was at EAW, they had DSA, digitally steerable array. Right. But it provides an amazing result to throw the sound where the people are and try not to throw it where they're not. There's just some fundamental concepts maybe that are easier said than done, but you're looking at the tools that we have available to us now. They are light years beyond where we were in the 90s. And so, it's something I think about the systems that I used on tour, because they were, these big array of point source, or, they're a big array of MSL 10s or MSL 4s or whatever, because I was touring with Meyer stuff. But you think about KF 850s and the pattern control that they really didn't have. And now they're much more exact about how they control where they throw their energy. Or conversely, there are times when you don't want control, you want to smooth a coverage pattern, and you don't mind being really wide open. And so you have consistency of coverage. I think that it roots fundamentally back into manufacturers becoming much more aware of the response of their systems. Measurement at manufacturers across the 90s, all of a sudden all the manufacturers started to really measure their systems in detail, not just octave measurements on 10-degree spacing, but actually getting down to 24th of an octave in 2 degree or 1 degree. And that's enabled a whole bunch of prediction. That's really revolutionized our world.
So just to circle back to where we started, it sounds like if I am working in a reflective or challenging room tomorrow, the first thing to look at might not be drive level, but it might be the signal source, direct to reverb ratio, and also speaker placement and aim. So, the sound system design itself.
Exactly. A cardioid mic.
Yeah.
Right?
Yeah.
And or cardioid subs that are throwing less energy backwards and more energy forwards. You play a violin, violins like big reverberant rooms. If you're miking a violin, the worst place to mic the violin is in close, because as you go around the instrument, you get a different sound field depending on where you are on the instrument. And the best place to mic that violin is, a few feet above, kind of at a distance, but it's also the worst place if you're in a reverberant room or you have a lot of other things going on. And so you have to bring the microphone in close, and you got better signal to regen, I guess you would call it.
Sure.
When cardioid microphones got introduced, I'm sure that just changed the world.
Oh, wow. I honestly never thought about that. I just always assumed that in sound reinforcement we had directional microphones, but no, that totally makes sense. Of course, at one point there were only omnidirectional microphones, right?
But yeah, because the omnidirectional microphone is is that it's kind of our stock and trade as measurement, because we want to take in stuff, just what's happening in the sound field. That's just a driver, a transducer hanging out in space, and you have to build in the interactions to create the pattern. And so it's something that we basically, we take the fader for granted as well. I mean, that's something that on a console that used to be big twisty knobs long ago. Take a look at the console that they did for Woodstock. They were building it actually as the show was going along too. So that's kind of funny.
Right. I guess the origin of being a sound engineer was that you would have to build your own mixer. I mean, I had Dan Dugan on the show a couple months ago, and his story is, classic. Like, he was a sound designer, was one of, the first, arguably, calling himself a theatrical sound designer. And, just to be able to have better shows and have his, operators be able to actually mix microphones and do a better job, he had to build a better mixer. That's what he did.
Our industry is built up of that. I mean, you look at, I don't know, guys like Jonathan Deems, who was doing the Cirque du Soleil stuff and shows where he needed many, many sources and many, many outputs to be able to pan things through. So he ended up being part of building his own system, his own equipment. Once we have it, we know what we need. I mean, this is what drives our programmers nuts sometimes, is that oftentimes we have to build something to know what we want to build.
Oh, sure.
And so that's a versional type of, that's the incremental innovation that we live in.
Jamie, you are definitely a champion of the growth mindset and, learning being more important than looking good or being important. So tell us about the biggest or maybe most painful mistake that you've made on the job and how you recovered from it.
Of course. I've worked for loudspeaker manufacturers, again, both Meyer and EAW, and have taken gear out into the field to see what it could do, and have a couple times had some catastrophic failures. Now that's a combination of not just me blowing up the gear, but also maybe not knowing where limiter settings should be placed and things like that. But I got to say that the most embarrassing thing is when I'm using the analyzer and something was wrong with my setup, and so I go and do a bunch of work. I had this happen once where I had a broken microphone.
Oh no!
And so I did like 45 minutes worth of tuning, and that was really embarrassing because I used up virtually all the time, and it it was a sort of a catastrophe.
It was
one
all
of the things,
invalid data.
Yeah, well, that's you got to verify not just your sound equipment. You have to verify your measurement system. That's what I teach in class. But one of the things that I always recommend for people to do when they're in a tuning process is listen. I'm not necessarily saying you need to do the tuning by ear, but the ear is part of that process. But it's a good chicken test. It's a good way to see if anything is wrong. If, let's say, you did a bunch of measurements with a bad microphone, you listen to something maybe Temptation by Diana Krall.
Temptation.
But you listen to something that through the system, and you'll get a good idea of whether or not you've messed up.
Mm-hmm.
It's like taste your food before you salt it.
Sure.
My process builds in a lot of stop and check points.
And is that how you found out? In this case, how did you find out that, okay, so you got to a checkpoint, you listened to the system and realized, oh no, something's
It's horrible.
wrong. Okay.
Yeah, but the place, I was 45 minutes into measurement and tuning. So you can imagine, so I've gone to multiple systems. I was only using one microphone at the time. And so we did a lot of microphone movements. And, certainly the timing decisions we made were probably okay, but all the tonal decisions were a complete mess. But then, there's other things where where I've gotten my ass handed to me a couple times in tuning, where in one case I went down to do a sort of emergency checkup of Sony studios in Miami. So I took my sim machine in there and went through their system, and they had some stuff that had gone awry. I forget why I was called in there, but I went through all their stuff and I did a tuning, and everybody was listening afterwards and said, "Oh, this sounds great, and this is wonderful. It sounds so much better." And of course, it's not a day later I get a call from them saying that, yeah, it sounds great, but it's unusable.
Oh no.
And well, the problem was that I'm a system engineer. I'm a venue type of guy, and there's decisions you'd make in a studio that you would never make in system tuning. In fact, there's one of the things that drives some of the stupidest things ever done in system alignment is when people try and treat a venue like a studio. And so I'm just doing sort of general curve shaping. And in the studio, you set that room up so that you have a very detailed, very controlled environment where you want left and right to be exactly matched. And so there was stuff. The general assumption you make when you're doing a tuning is on a system is that you're matching left and right drive and EQ if the room and the system are symmetrical. It's just a way of saving time. But the thing is that in the studio, you're matching the response left and right at the listening position. So we just had to have our friend Bob Hodis followed up and finished the tuning. So I just set the table. I went with my friend Jeremy. It was a system that was a bowling alley and a club. Really kind of cool place.
Okay.
And we marched through this system, and we tuned it like I would in a process that I would like tune a normal system, a normal sound system in a theater or something like that. And we got done, and we listened to it. And we started by listening, I don't know, by Nightfly or Temptation or who knows what I was listening to. And it says, oh, okay, this sounds okay. But then we listened to club music, and it sounded sterile or neutered, or it was just not exciting.
Uh-oh.
And you realize that in a club, you're not looking for imaging. You're not looking for intelligibility per se. In fact, you kind of want to scoop out the mids so people can talk to each other.
But you need that hype.
But the most important thing was that you really, in most listening environments, the listener is staying in one place and listening to the system. You want everybody to get the same show. In the case of a club, you're moving throughout a environment, and you want a sense of movement in your system, and you want a tonal consistency so that the tuning, instead of using and working hard on the timing between systems and imaging, that doesn't matter. What matters is constant tonality. And in fact, what's a negative in a theater sound system is a plus in the club system. I move my head around and I get this flanging phasing between these tweeters that are cross-firing.
Sure.
That's danceable. That's really exciting. And so we I think we worked for like 2 hours tuning the system, and then we threw that away and we went back and just tuned it by RTA, and it was great. It was totally different aesthetic.
Jamie, what's in your work bag? What do you take with you to work on these shows?
So my smart kit is my computer, my preamp. I happen to use a Roland Octacapture normally because it allows me to get about 8 microphones. It's compact. There's a lot of great preamps out there. That one just happens to fit in my kit really well,
okay.
And it's been trustworthy. And I generally carry 5 microphones. I mean, I will carry upwards of 8, but I really only use about 5 microphones. Oftentimes, I'll carry one wireless. Measurement quality wireless. I use Electrosonics. Is really a helpful tool.
Yeah.
I mean, it's kind of expensive.
I want one.
You can get a lot of wire, a lot of cable for the cost of the wireless, but in a lot of environments, it just becomes incredibly freeing. I mean, one of the things that takes the most amount of time is just running mics and the damn mic cable.
Sure. Hate that stuff.
And so but then along with that, external to my Smaart kit, a lot of cables and adapters, but cable checkers. And I like rats, little sniffers. We sell them in our store at rationalacoustics.com. That's rationalacoustics.com. So we sell the sniffers. What's great about them is that it's a send and receive. So oftentimes you can't have both ends of the cable at the same time, like a cross stage snake or something like that. And so being able to send and receive helps in teching stuff. I mean, nowadays there's no excuse for not having a cable tester. I mean, there's some great ones out there that are relatively inexpensive. The cable checker you got to remember you have to have is not just for audio cables, but for data cables, which are audio cables now. So you need to you have to check your USB cables, you have to check your Ethernet cables, your RJ45. You've got to have a cable checker for that, because that's one of those insidious things where you don't expect that your connection between your preamp and your computer is what's bad, and that assumption has eaten up huge chunks of time sometimes. So those USB connections are, I think, only officially rated for like 500 connections.
Yeah, it's kind of like worlds collide now, right? Like you have this world of computer IT where, maybe connections get made once and then they sit there forever. Or these USB cables where they just sit on someone's desk and they don't, they're not getting taken all over the world and into the worst environments. And so now we're using those on our shows.
Yeah. Well, it's the only good thing about it is that those are types of cables that are available all over the world.
Jamie, anything else from your work bag that you want to share with people?
Tiny
bottle of scotch, cigarette,
a flashlight.
Sure.
You have to have a flashlight.
Yeah,
I was going to say flashlight, laser pointer, and of course a holder for my white gloves. One of my first day, it might have been my first day, it might have been my second day at Meyer. I was in our office. I say office. The support department was a hallway between the electronics production and the demo room at Meyer. John showed up in the office, and he was pissed off because so the SIM analyzer was a 486 motherboard with 3 aerial DSP engines on it, and so it was basically a computer with some DSP cards mounted to it and a delay card and stuff. And so he was asked by one of the companies that bought a SIM machine. There were only like not 3 or 4. There's only about 10 companies that had them. This happened to be a Canadian company. Their name rhymes with Solotech. And they wanted to know if they could use their laptop instead of the motherboard, right? And so it's just a 486 motherboard. Can I have a laptop that hooks to this SIM machine? And John was like, he was pissed off because he very much believed that he wanted the analyzer to be a dedicated piece. Mm-hmm. It wasn't also a computer that you use for doing other things. It was that 486 motherboard was just there to manage the whole system. But the thing that I recall the most is like, if we allowed people to use their own laptops, we would be spending so much support time just supporting their laptops and operating systems.
Right, which is what you do now.
Yeah, and that's
I remember,
and it comes back to haunt me. It's like we do as much OS support here sometimes. When each operating system decides to break itself, we end up doing support on that as much as we can. We've got a woman, Liz, who does all our license support and computer support, and she's kind of a kid for us. She's in her early 20s, but she kind of grew up on operating systems. So they're second nature to her. So we have
Sure.
a bunch of old dogs that call us up that are, guys that were raised on analog and are now forced to deal with computers, where, she sits there and will talk them through detangling their operating system. And so John saw that coming 20 years ago.
Jamie, what is one book that has been immensely helpful to you?
Siddhartha by Hermann Hesse. You think about where we're dealing with very complex environments and complex people and interactions and things like that. And one of the things that I've learned in doing this is that it's not all about you. Oftentimes, your ability to get out of other people's way and let them do their work is more important than you getting that nth degree out of the system. And I've seen some great mix engineers that were great, babysitters, or not babysitters, but they're providing confidence to the artist. And so if an artist walks in and hears 2 hours worth of noise and working on a system and nasty stuff, and you lose confidence from the artist or from even the mix engineer, even though you have a great sounding system, the lack of confidence or the problems you've caused by stealing time from other people, the net is you're getting less out of it than if the quicker I can hand the system over to the mix engineer and I'll clean stuff up later, but allowing the process to flow and, knowing when to just put up with it and don't kill yourself, because you're never going to get perfect. So just don't make your environment less habitable by fighting real hard to get to perfect. It causes stress. Bob's book is a great exploration into this stuff. The Yellow Book, the Yamaha Sound Reinforcement Handbook, they're all great books, but I think that in the end, they're references. I think that it's a methodology and a mindset that will help you survive.
Jamie, where is the best place for people to follow your work?
RationalAcoustics.com. It looks like we're going to change offices. We're going to expand our office, but one of the things we're going to do is we're building a training room. So that
Nice.
one of the biggest questions we get from people is, where can I get level 2 hands-on stuff? And really in the classes we do, it takes a lot of prep to do hands-on classes, and you can't do it for a lot of people. And we're going to start doing level 2 hands-on training at our facility. So hopefully in the new year we will have a place where people can come and do 1 or 2 or 3 days worth of hands-on training, and that will allow us to reliably add that in.
Well, it sounds like exciting things coming up for Rational Acoustics. Jamie Anderson, thank you so much for joining me on Sound Design Live.
Thanks, Nathan. I look forward to hearing what you made out of this, but it was definitely a pleasure.
Sound Design Live. I want to thank the band Heavy Moan for all the music in today's episode. If you want to find more of their music, you can do that over at soundcloud.com/heavymoan. Sound Design Live is supported by Bob, David, DC Sound Op, Ellis, Senquay, Joel, and Megan. You can start supporting Sound Design Live today for as little as $1 over at patreon.com/sounddesignlive.